Welcome to this explainer. Today we're looking ahead at a period of really profound interconnected change. And to be clear, we aren't just talking about a few new gadgets or software updates here. We're entering what's being called the smart decade, spanning from 2026 all the way to 2035. Based on some seriously comprehensive research covering everything from global business strategy to cutting-edge physics, we're going to explore the massive tectonic shifts that will fundamentally rewire how we live, work, and operate.
All right, let's just dive right into this. It's a simple but honestly pretty provocative question. Are you ready for the smart decade? Because the truth is, the sheer velocity of the technological, biological, and economic changes heading our way is completely unprecedented. We are about to see the boundaries between the physical, digital, and biological worlds blur entirely.
But here's the thing, take a look at this number. According to a massive global survey of over 10,000 senior executives by McKinsey, a staggering 72% of leaders report that their organizations are not fully ready to face these upcoming changes. 72%! The stakes are incredibly high right now. These shifts are deep, structural transformations that are going to test literally every assumption we have.
So, here's our roadmap for today. We'll be looking at 1. The rise of agentic AI. 2. The biorevolution. 3. Deep tech. 4. Connectivity and space. And finally, 5. The leadership challenge.
All right, let's kick things off with Section 1, the rise of agent AI.
So we're moving way beyond those simple chatbots you might be used to interacting with today. The future is all about true digital workers that are actually capable of executing multi-day, complex workflows with a ton of autonomy. Let's break down how an AI agent actually functions, because this is where the real magic happens. Basically, an agent combines a reasoning module with a memory and access to tools. It's a framework known as scaffolding. Step 1, you give it a goal, and it uses its reasoning to make a plan. Step 2, it uses digital tools to actually take action in the real world. Step 3, the results are fed back into its memory. And Step 4, it updates its plan and loops right back around. So, if you tell an agent to build an app, it doesn't just spit out code. It actually asks clarifying questions, builds a prototype, tests and fixes bugs, and delivers a finished product. Honestly, much like a human engineer would.
Now, what's really interesting about this image here is the sheer physical reality behind all that digital intelligence. Inside these massive data centers, the digital power of agentic AI demands an intense and, quite frankly, unsustainable amount of physical energy and computational waste. We're hitting a wall with our current silicon architecture. I want you to keep this energy problem in the back of your mind, because we're actually going to solve it in just a few minutes.
Moving right along to Section 2, the biorevolution and longevity.
We are in the middle of a profound pivot in medicine right now. We're moving away from just treating existing diseases and shifting toward proactively targeting the biology of aging itself. So how are we actually going to pull this off? Well, here's a map of 3 major breakthroughs driving this revolution. First up, GLP-1s, which have totally made aging biology mainstream by proving that metabolism, inflammation, and our overall health span are deeply, deeply connected. Second, senolytics. These are fascinating therapies entering human testing right now that target and literally clear out zombie cells that accumulate in our bodies and cause aging. And third, epigenetic reprogramming. This is an incredibly elegant approach that uses transcription factors to reset a cell's age back to a youthful state, entirely without increasing cancer risk. And Big Pharma is absolutely fully on board here. Novartis, for example, just launched an entire aging division and struck a massive $550 million deal with BioAge Labs to discover novel therapeutic targets.
And this detail perfectly captures why this is a true revolution. The FDA and EMA are now officially accepting aging biomarkers, things like your gait speed or your sleep patterns, as clinical endpoints. This regulatory breakthrough is massive, guys. It means pre-disease functional decline and extending health span are now legitimate, measurable therapeutic targets in clinical trials. Researchers don't have to just wait around for a specific disease to take hold anymore.
Okay, Section 3, deep tech, computing and energy.
Remember that massive AI energy problem we discussed a minute ago? Well, to solve it, the silicon status quo basically has to end. We're about to bypass the limitations of traditional hardware through some radically new approaches. Just compare our current silicon computing, which has incredibly high energy waste, to neuromorphic computing. Neuromorphic chips are physically designed to mimic human neurons. By the time we hit 2026, chips like Intel's Low i3 and IBM's North Pole are bringing this brain-inspired computing right into the mainstream, promising up to 1,000 times the efficiency of traditional processors. We're essentially embedding sustainable intelligence directly into our physical environment.
And as for the raw energy to power our future, it's literally coming from the stars. The timeline for nuclear fusion is accelerating so much faster than a lot of people realize. In 2026, Commonwealth Fusion Systems expects first plasma testing in their Spark reactor. By 2028, companies like Helion are actually targeting commercial power delivery. And by the early 2030s, we're looking at true grid-scale deployment. But what is absolutely wild here is the cross-pollination of these tectonic shifts. Google DeepMind's AI is actively being used right now to control magnetic configurations and manage heat loads inside that Spark fusion reactor. AI is literally helping build the clean energy source that's going to power it. It's amazing.
Next up, Section 4, Connectivity, Mobility, and Space.
So as we start generating boundless clean power on Earth, we're simultaneously expanding how we connect globally and pushing further into orbit. Arriving in the early 2030s, 6G is going to completely redefine what networks can do. It's not just about speed anymore. It's an AI-native, intelligent fabric. We are talking about true global internet coverage that blends macro cells and satellites together. It's going to enable wide-area, mass-market, mixed reality, seamlessly integrating the physical and digital worlds. It'll provide the exact real-time positioning required for fully autonomous mobility, and because it's AI-native from the ground up, we're going to see networks operating autonomously with absolutely zero human touch.
But this connectivity isn't just terrestrial. With the International Space Station scheduled to retire in the early 2030s, we're witnessing a monumental transition in low Earth orbit. As this quote points out, NASA is stepping back from being an operator to becoming a customer. The future of space is a highly competitive marketplace of private, commercial space stations built by companies like VAST, Axiom Space, and Starlab. And these orbital platforms, they're going to serve as microgravity labs for advanced materials manufacturing and pharmaceutical development, directly fueling that biorevolution we discussed earlier.
And finally, Section 5, Conclusion, the Challenge of Leadership. We have covered a staggering amount of technological scale today. I mean, from multi-day AI agents and cellular reprogramming, all the way to neuromorphic chips, fusion energy, and commercial space stations. But for our final shift, let's slow things down for a second and bring all of this back to the most crucial element, us. Consider this flock of birds moving in perfect fluid synchronization. This beautifully illustrates exactly how organizations are going to have to operate in the smart decade. In a world of constant geopolitical shocks and hyper-exponential technological change, organizations simply cannot be rigid. They have to develop a deep-seated adaptability and psychological safety, allowing the entire group to pivot, bounce forward, and recover seamlessly.
Because as AI takes over more of the execution and complex problem-solving, the value of uniquely human capabilities, it skyrockets. The old command and control models of leadership are completely dead. According to McKinsey's research, the smart decade requires true human-centric leadership. It requires humility, empathy, vulnerability, and deep listening. Leaders have to prioritize self-awareness and create environments where teams actually feel safe to experiment, to fail, and to learn right alongside their AI counterparts. Leadership is really becoming as much an inner journey as an outer one.
Which leaves us with this final thought. Over the next 10 years, we are going to deploy technologies that rival magic. But technology is just the tool. Humanity is the purpose. As technology masters the complex, will you master the human? I really want you to reflect on your own role, your own adaptability, and your own leadership as we step into this smart decade. Thank you so much for joining me for this explainer, and I'll see you next time.